Hi guys, how are you? I hope you are fine. Today we are going to talk about maybe it's difficult topics or something you can say challenge. Yes, challenge topics. Here we are going to speak about BGP, basics and advanced. As you see here in our scenario, in our topology here, we have many routers and we have different autonomous system. As we see here, we have three routers, router 1, 2, and 3. They are included in autonomous system 100, sorry, for BGP and OSPF area 0 here. I want to include also the IGP with OSPF. Also here we have autonomous system 200. This is external BGP included for router 1 for this interface and for this. Also router 6 included for autonomous system 300. As you see here, includes this interface and this. And the last one is autonomous system 400 included for router 5. In this video, I'm going to speak about many points. Yes, about many things. I want to cover many advanced topics in BGP. As you see here, go to the left side and see what we are going to cover today in this video. We are going to talk about 8 things. Yes, 8 points here. A lot of things. So now the first thing we are going to configure OSPF with area 0. This is the IGB, sorry. And here is we are going to configure IBGP and EBGP, internal BGP and external BGP. The first step here, we are going to make sure router 1 to reach to all network loopbacks. That's like here. I want to make router 1 to reach all router 1 here to reach to all loopbacks for router 4, 6, and 5. To choose router 2 to go through this way, to go through this way. What we have here. Yes, make sure router 1, make sure router 1, yes, make sure router 1 can connect to router 2, 3, 5, 6, and 4 with each loopbacks here, because each router here, it has loopback. Router 1 loopback 1.1.1.1, 2 is 2.2.2.2, 3 is 3.3.3.3, 4 here 4.4.4.4, it has a loopback here, and also here 6.6.6.6. The last one 5 is also loopback with 5.5.5.5. Here is in my exception here, router 6, I have 2 loopbacks interfaces. I have 6.6.6.6 and also 60.60.60.60. I will show you now. I did the pre-requested configurations here, each IP addresses for each interface, and also I did the loopback interfaces also for each router. So this is the second one. The third one, or the third point here, we are going to make router 6, which is 6.6.6.6. This is loopback. Yes, because router 6, it has 2 loopback interfaces. So I want this loopback interface to choose router 5 to reach to the router, to reach to the router 1. What's that mean? Here is it. I want router 6. Yes, with loopback 6.6.6.6 to reach to the router 1 through here, through router 5. Yes, through router 5 to router 3. Yes. So I don't want to use local preference either. I don't want to use also the metric. Here's I want to add also also med. We don't use med and local preference. The 4 points, the fourth point, yes, here is make all outside networks. Yes, make all outside network to go through router 2 when come, yes, from router 1. What does that mean? I want to use local preference here. I want to use router 1, yes, to choose router 2 to go through router 4, 6, and 5. Yes, I want router 1 to choose router 2. This is the best way to go to the router 4, 6, and 5. So the fifth point here, I want to make router 1 to choose router 3 to choose 6.6.6.6. Here is it. I want router 1 to choose router 3 to go through router 6 with loopback interface 6.6.6.6. And also here with specific local preference. And also here I want to use also router 1 to reach to the router 6 with this loopback interface with to reach through router 3 also, and also make router 1 to choose router 3 to reach all networks or all routes in Autonomous System 400. Look at this here. I want router 1 to choose router 3 to reach here for all, yes, for all interfaces, for all networks in Autonomous System 400, which include this fast Ethernet and this serial, and also the interface loopback. And also the last one here, I want to make a load sharing balancing between router 2 and 4 here. I want to make load share balancing because here I have the double link. Yes, I have a double link here. So I have many things here. To be honest with you, I spent maybe 2 weeks or 1 week and 5 days to prepare this, yes, to prepare this video because it has many points, many topics here, important topics about the BGP basic and advanced. There are many things about BGP also advanced. I want to cover it in the other videos, inshallah, but here's now I want to speak about those topics, yes, what I said before here, the 8 points here. So now let's get started now. So go to the router 1 first and configure the first step here, configure OSPF 0 and configure IP BGP and eBGP. So go to the router 1 now I want us just to show IP protocol. I don't see anything. Show IP interface brief here. Look at this. I have here is loopback with 1.1.1.1. So I want to configure the OSPF first with router 1, router OSPF 1. Here is I want to advertise all networks. So I want to advertise this and this and this. So I want to use 0 to 0, 0, 0 is 255, 255, 255, 255 with the area 0. Like this. I want just to make this yes, I want to make this net commands, yes, to advertise all networks for router 1. So go to the router 2 now. Yes. Show IP protocol. Do we have anything? No. Show IP interface brief. Here is it. Look at this. I want just to advertise this network to include an OSPF this and also the router ID. So I don't want to advertise for this interfaces. Yes, I don't want because here is I want to include it in the BGP. So I want to include serial 00 and serial 01 in OSPF protocol. So I want just to like this router OSPF 1 with network. So now I want just to advertise for router 2 here for this network, as I said, this and for the loopback interface. So the first one is 92168 dot 0.0.0, sorry, 0.255 with area 0. The second one is 3.0. Yes, and here is my loopback network. Sorry, 2.2.0 with 0.0.0.255 with area 0. Yes. Now go to the router 3. Here's it. Now we are going to configure OSPF router OSPF 1. I'm going just to, before that, do show IP interface brief. I want to advertise this network and this just. I don't want to advertise for 0.0.0 because this is, I want it for external BGP. I don't want to include it in the internal with the internal GP. So now I want to network 192.168, sorry, 192.168.2.0 0.0.0.255 area 0, and also here with 3, and also here 3.3.3.0 or 0.0.0.25. What's that? 255 with area 0. Now we configured the OSPF. Now we are going to configure internal BGP and external BGP. The first thing I want here to configure the internal BGP to use the neighboring with loopback interfaces. I don't want to make a neighbor with this fast Ethernet with this loopback interface fast Ethernet 00. I want to make it by the loopback interface, attached by the loopback interface, and also I want to use update source loopback 0. So here is it as I want to do. Router 1. First of all, show IP interface brief here as we see here. Yes. So here is the loopback of 1. I want to go to the router 2. Just I want to show you here. What's the show IP interface brief. So I want to attach router 1 with neighboring with this loopback interface with router 2. Yes. So now go to the router 1 here, like this. Conf T, router BGP, here is autonomous system is 100. Sorry, now we are going to make a neighbor 2.2.2.2. This is a neighboring with router 2 with this loopback interface. Remote autonomous system, the same autonomous system. Now I want to make this to attach it with update source loopback interface 0, and I want to make a neighborship between router 1 and router 3 also with a loopback interface. The loopback interface of router 3 is 3.3.3.3. So now 3.3.3.3 with remote autonomous system, the same autonomous system, and also don't forget to make update source loopback with 0. Now we finished in router 1. Go to the router 2. Yes, I want to make conf T router BGP 100. I want to make a neighbor also router 2 to make neighboring between router 1 and also between router 3, because I have here is a fast Ethernet link. So now go to the router 1 with the loopback interface also. So with the remote autonomous system 100 with update source loopback 0, and also neighboring with 3.3, which for router 3 with remote autonomous system, yes, 100. Same thing also here with update source loopback. Now we are here, we have adjacency, BGP adjacency with router 1 and router 2. So that's good with loopback 0, yes. Now go to the router 3. complete the IBGP. What is it? Here is it. Now exit here because we are in router OSPF. Now router BGP 100. Now go to the making neighboring with router 1 with the loopback interface 1.1.1.1 with remote autonomous system, the same autonomous system here. And also don't forget to make update source loopback with source loopback 0, and also neighboring with router 2.2.2.2 with remote autonomous system 100, and also make it by update source loopback 0. Now we are going to have, look at this, we have adjacency between router 1 and also router 2. That's good. So now we finished the IBGP. I want to make the EBGP external. The external just I want to make it on router 2 and router 3, 4, 5 and 6. Here's it. So now go to the router 2 first. Minimize this, router 1. I want to router 2 to make, just here is, look at this. I want to make, I want to use just the upper link with 000 with 000 with this IP address. The second one I want to use it in the next points in this video. So just here's I want to use just one link now. So now go to the neighbor. I want to make a neighboring between 172.16.0. here is it, router 2. I want to make it by the next hop of serial 00 here with 172.16.0.2. So this is the neighbor with remote autonomous system. Here is, don't forget to add 200 because this is the external. Now here is, I don't want to use update source loopback here because here is it, I make the neighboring with the serial interface. So now go to router 3, yes, and make also the external BGP. Yes, here's it, neighbor with 172.16.0.6. this is for router 5. This is the fast Ethernet 0 with 172.16.0.6, like this, and also with remote autonomous system. The remote autonomous system here is 400. So now it is 400. So now we finished on autonomous system 1 to make the IBGP and the EBGP. So now go to the router 4. Sorry. Now go to the router 4. Yes. Now go to the router BGP. What we have here, 200. Now make a neighbor, external neighbor, yes, between router 2 and router 6. Router 2 I have here 172.16.0.1 here, my neighbor, with the remote autonomous system, sorry, with remote autonomous system 100. Now the second one is between router 6, which neighbor here I have 192.168.4.6 with remote autonomous system 300. Yes, that's good. Now we have adjacency, that's good, with the router 2. So now that's nice. Now go to the router 5. Yes, and also make conft, sorry, router BGP, here is it, with 400. Now go to make neighborship between, sorry, neighboring between router 3 and router 6. Yes, with 52 and 16.0.5. Yes, with remote autonomous system 100. and also neighboring with 192.168.5.6 with remote autonomous system 300. So now I should see the neighborship between router 5 and router 3. So that's good. Now I see the neighborship. Yes. Now go finally to the router 6 and make also. Look at this. Here's I have two loopback interface as I said before. Sorry, here's and here. So now conf g router BGP. Here's the 300. So now go to make a neighborship between router 4 and router 5 with the IP address of fast Ethernet 00 and fast Ethernet 00 here. Let's begin for router 4, 92.168.4.4 with remote autonomous system 200 and neighboring with 192.168.5.5 with remote autonomous system. Here's I think 400. Yes, with 400. Here's I should see the neighbor distances between router 6 and 4 and router 6 and 5. Yes, that's good. Now I have it. So let's go back to our points here. We configure OSPF, we configure EBGP, IPGP and EPGP. Now I want to make sure that router 1 to reach to all networks loopbacks interfaces. As I want to make sure with router 1 to reach to all networks here. So go to the router 1. Now let me just verify show IP BGP here. I don't see anything. Show IP route. Yes, I have here the OSPF just. I don't see here's any BGP route. So that's very clear to know. We didn't do the network. We didn't advertise this network and this network and this network. So we didn't advertise it. So I need to advertise also router 5, 6 and 5. I have to advertise the network which attached for. So here is I need to make conf t router BGP. Just here I want to advertise the loopback interface. Just first of all 1.1.1.0 with mask 255.255.255.0. So this is the first one. Now go to the router 2 and want to make advertised for this network and this and this. So go to the router 2. I want to make a network for 192.168.1.0. Here is I don't need to make a mask because this is a classful, so I can hit directly. And also with 3. Yes, don't forget the loopback to the 2.0 with mask here. I need a mask. Yes, because this is classless now. So go to the router 3. Yes, with network 92.168.2.0 and also with 3.0 and also with the loopback 3.3.3.0 with mask 255.255.255.0. So now if you go to the router 1 and make show IP BGP, now look at this. I can see our BGP internally. Yes, 1, 2 and 3, 1, 2 and 3. So that's nice. Show IP route BGP. So here's I have this and this. So that's good. Now yes. So now what we have here, we have also to make a network or advertise the network in router 4, 6 and 5. So go to the 4 first. and make a network for this network from 192.168.4.0. Yes, and also a network with 172.16.0.0 with mask 255.255.255.252 for this network. Yes, and also advertise the loopback interface with router 4 mask 255.255.255.0. So now go to the router 6 and advertise this network and this network and also the loopback interfaces with 6 and 60.60.60.60. Now go to the network first for 992.168.4.0 and also 5.0 and the loopback interfaces 6.6.6.0 with the mask 255.255.255.0 and also here it's easy just like this 60.60.60.0 and also adjust. Yes, that's enough, and go to the router 5 finally. Now make a network also router 5, where is it? Here is it. Now go to the advertise this and this network and also the loopback. So go to the network 192.168.5.0 and network 172.16.0.4 with mask 255.255.255.252 and also network the loopback interface with 5.5.5.0 with mask 255.255.255.0. So now what do you think to go to the router 1? Show IP BGP. Let me see here what we got it. Yes, look at this. I have 4 and we have also 6 and we have 60 and what is router 5? Let's see, maybe because now we are going. Yes, takes a time just. Here's it. Look at this. We have for router 4 and router 5, router 6 with 2 loopback interfaces. So that's good. Now can we make a ping? Let me see just if we can. To 1, we'll ping from 1 to 6 with 6 with 6 with 6. Look at this. Until now we cannot make. So why? Let me just to make with source loopback with source loopback 0. Also I can't. So that's easy now. I want to show you how. Show IP root BGP. Look at this. I can't see it here in my IPGB, but until now I can't choose the best way. Look at this. I don't see this sign. This sign, it means choose the best way. I don't see here. Yes, router 4 I can see it from router 1 with 2 ways, but until now I can't choose the best one and I can't see it in my BGP. Here is, I have to think here. Look at this. Here is yes, router 1 can see the router 4, 5, 6 with this next hop, and this next hop is the next hop of serial. Yes, of serial interface, not the next hop of the neighbor ID. So what I want to do here, the first thing I want to make it to make a next hop with neighbor ID. That's easy now. I want to go to the router 2 and router 3, make next hop self with router ID here like this. Go to the router 2. I want to show you here. So now go to the neighbor here, router 2. I want to make neighboring with router 1 with next hop self, and router 3 with router 1 next hop self also. Go to the router 3 and also network with 1.1, sorry, neighbor, not network, neighbor 1.1.1.1 with next hop self. So now if we go to the router show IP BGP, look at this. Now I can see the ping. Yes, look at this. I can see the ping with next hop, and here is now I see the best way. Look at this. Before that I couldn't see it. Look at this. I don't see the best way. So now I can see it. So can I ping to the 6? Yes, now I can ping to it. Yes, so because I did the next top self solve this problem for me. So now go, can I ping to 60.60.60.60.60? Yes. Can I ping to, wait a minute, to 4.4.4.4? Yes. Can I ping to 5 with router 5? That's good. Now just to make sure, I want to go to the router 6 and make a ping to the router 1 just to make sure I have a full connectivity. Go to the router 6. Now here, show IP BGP. Do I have anything? I can see router 1, it goes through this way, so no problem, and this way and this way. So now what we have here, I want to make show IP root BGP. Do I see anything here? Yes, I can see to the router 1. So can I make a ping to the 1.1.1.1? Yes, that's true, I can ping to it. So can I ping to with 2.2.2.2? Yes. Can I make ping with source loopback 0? Yes, that's good. So now I have a full connectivity here. I can make a ping. I have many screens today. So now we can ping from router 1 to all outside network and also inside networks. And also I can make a ping from router 6 to the outside network here also. So now just I want to show you something here. Router 1, show IP BGP. Before that, start. Look at this. Router 1 can see the router 4. Yes, with this next hop ID. So that's what I want really to do, because here is yes, look at this. Now it's used, here is it, and also 5.5.5.5, it can use this. So now just I want to make a right. So now I'm going to show you something here. Just show IP BGP here. Yes, look at this. I am in router 6 now here. Look at this, router 6 can see the router 1 with 2 ways through 192.168.5.5 through router 5 and through router 4. Look at this, but router 6 prefer this IP address, this next hop, which for router 4. So why? Because here, look at this, the 2 path here, it has the same local preference, the same metric, the same weight, and also the same autonomous system path, the same path. So if all of these, they are the same, so now the last match thing, I think it will be the neighbor ID. Yes, because it takes the lowest neighbor ID. So this is the lowest than this. So router 6 prefer this way. And also look at this, for router 2 also prefer this way. For router 3 also prefer this way, because it has the lowest neighbor router ID for the lowest neighbor ID for this network, because all things here we have the same. If we go to the router 1 and show IP BGP here, look at this. Router 1 can see router 6, yes, through this network, yes, and can see router 5 through this network, because this network, it has lowest autonomous system path. This is 200, 300 and 400 to reach to the 400, but here on this next hop it reached to the 400 just one hop. And also here it takes, because they are the same autonomous system path, it will take the lowest neighbor ID. Look at this, takes 2.2.2.2. This sign, it makes this sign means choose the best way. So This is very, very important to know it and to verify it here. So what we did here, go back to our points here. We make sure so router 1 can reach to all network loopbacks. Now to talk about the third thing. We want to make a router 6 with loopback 6.6.6.6 to choose router 5 to reach to the router 1. So here is, I want this loopback interface which located in router 1 and router 6 to reach to the router 1 through router 5 and 3, then go 1. So go to the router 6 now. We want to show the path. The path, it's take the router, look at this, takes the upper one, the router 5. I want to choose to take the router 6. Here is, I can't make this through metric or through local preference. Through metric I can't here. Why? Because this autonomous system, it's not directly connected to this autonomous system, so I can't make the, maybe with access list with interface loopback 1.1.1.1 to give it the metric with lower than this or higher than this to choose the lowest one. But here we can't do this because this autonomous system, it's not directly connected with 100. So what we are going to do here, we are going to router 6 and make or choose the prepended solution. What does that mean? The prepended here, I want just to make a trick for router 1. I want to make a trick, just I want to say to the router 1, say router 1, hey, you can see this, or for router 6 you can't go through this way, because this way it's highest autonomous system paths, so it takes a long autonomous system path than this. So this is prepended. Prepended, it's just such as a trick, yes, to trick router 6 to see this path. It has a long autonomous system path, but here just 2 paths. Here is, I want to make it more than 2 paths, so I want to make a trick for router 6. So go to the router 6. I want to show you how to do this. Go to the router 6. Before everything here, I want to make an access list. Access list to match this. Access list to match this. Yes, to match this. So now go conf t, go to access list number 1, permit 6.6.6.0 with 0.0.0.255. Now I want to apply this access list with route map. So go to make a route map here with name, maybe you can say prepend, like this, with permit 10. Now I want to make a match. First of all, match IP address, match this access list 1. Now set the autonomous system path prepended. Look at this. I want to make more than 2 path like this, because it's 300, to take this 300 way, 300 autonomous system, and also this autonomous system path, and also this autonomous system path, and 3. I want to make more than 2, more than 1. I think here I did 4 just to show you how did this work. Now it's very, very important to make the second line of route map, because otherwise than this it will be denied like this. Yes, don't match it. So now I want to apply this route map inside the router BGP 300. Now because the router 1, it comes from this way, I want to make a neighboring with 192.168.4.4. Look at this. I want to match the route map this name. Here is, look at this, I want to use in or out. Here is, I want to use out because I want to advertise 6.6.6.6 with this dependent autonomous system. So here is, I want to make out, not in, because the loopback interface 6.6.6.6, it comes out from router 6, not comes in. So here is hit it out. Now I want to just to make it clear IP BGP star. Here's, I want to use soft just because if I did this without soft, it will take a long time and it will use the CPU usage and we waste our time. So I want to make it just quickly like this. So now if you go to the router 4, now I will show you how will this happen. It's very, very interesting. Look at this. Show IP BGP. Look at this. Look. Very, 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 very interesting. Look at this. I make a trick for router 6. Look at this. I make this router 6. Look at this. It takes this autonomous system path. So it takes a long path to reach to the 6. Yes. So here is very, very, very autonomous system. Go to the here's show IP BGP. Look, if we have any change here, we don't have anything. So no problem here. So now I want router 1, just go to the router 1. So show IP BGP here, look at this. Now BGP, it takes the lowest one, look at this. Before that it was take this way, yes, because it has the lowest. So here it uses this way. Look at this. It uses this way to reach, because this way it is lowest autonomous system path. So it uses a lowest system path. But if you go to the router 2, go to the router 2 here and show IP BGP. I want to show you something here. Look at this. If you want to use, yes, because here's to reach the router 6, to use also this. Look at this. To use this way, the under 172.16.0.6, because this is the lowest path way, the lowest autonomous system path. If you go to there, you will go through longest, yes, autonomous system path. So it will choose the lowest one. So this is very, very interesting. This choice, we make router 1, yes. We make router 1 to reach to the router 6 through this way, yes, by prepended, not by, I can do this by local preference. I can make local preference here to make highest local preference. But suppose you are working in this autonomous system and you want to make router 1 to reach the router 6 through this way. You don't allow to change anything here. So this is our points here. We apply it. So we did it, and very, very, very nice, very, very successful. Now you can test this by trace route to the 6. Now look at it, choose this way through router 3 to the router 5, yes, as I wanted. So that's very, very good. So we change this, yes, we did this. Choose router 4, yes, make router, here's just we need. So now just I want to change this, just because this some mistake, to change to make router 1 to choose router 5 to reach to the router 6 with loopback 6. Let's 6. So that's good. Without use mid or local preference, we did this by prepended. So that's very nice. Now the point number 4 here, I want to make all outside network to go through router 2 when comes from router 1. So look at this. I want to router 1 to reach to the all outside networks here, yes, to reach to all outside loopback interfaces through router 2. That's very easy. I used hint here. I want to use a local preference. So suppose you are working in this area, so you want to make router 1 to reach to all networks here through this way, through router 2. So go to the router 1 first and make show IP BGP. Look at this. All of them, some of them, they are going through this way. because it has a lower one. But here I want to make a local preference to force, yes, to enforce router 1 to go through this way by local preference. So what I want to do here, I want to go to the router 2. Look at this, it's very, very nice. Go to the router 2 now. I want to make sure, just to show, sorry, I don't see anything. Yes, I want to make a local preference here to be the highest more than this. The default is 1. I want to make it 200. Yes, router 2, and want to just I don't want to use access list, because here I want to apply it for all networks. So just what I want to do here, I need just a route map with local preference permit 10, and just here I want to use set local preference 200. I don't need to make another line of route map, because here is I want to apply it for all. So just make clear IP BGP star soft sorry. So I need to do this to make it quickly just. So if you go to the router 1, now you will see all local preference here change. Look at this, show IP BGP 200, maybe it takes, oh, just sorry, we didn't apply this in route map. So go to the router BGP 100 and want to apply this, yes, to apply this route map and neighboring. So this neighbor 172.16.0.2, here is router 2 is neighboring with router 4 by this interface. So the 2 I want to attach with the route map here. Look at this, I want to use this name because this is the route map. Here is, I have two choices, in or out. So because I want to local preference, it means, so any, yes, any network, yes, any IP addresses comes from outside network through this way, please give it the local preference 200. So this is that means. So I want to use here in, because local preference, it deals with the outside or external autonomous system networks. So here's, I want to use N. Now I want to use this clear IP BGP star soft. Yes. Now go to the router 1. Now we will see the change. Yes, look at this. I have, here is some change here. Look at this. Here is, I have the outside network is choose the 200 because it is the highest than 1, and also 5 it choose 200, the highest, and also 6.6 here I can't, it doesn't match because it match in the router map. Yes, the router prepended, because I did here prepended, so prepended it's override the route map. So just, and also 60.60.60 comes through this. So what I want to do here really, make all outside networks except, you can choose this, except, yes, 6.6.6.6, because 6.6.6.6 it's override by this step, yes, by step number 3, so it will not include it in our network. So that's very, very nice to know it. So go to the back router 1 again, and I'll show IP BGP also. Yes, now we say it to take, yes, as you see here, look at this, it use this, yes. So that's it, that's very good. 60 also, look at this, to use this through this local preference, because it prefers this local preference, yes. So that's good. Now it uses the local preference, even if this path it's two-way. Look at this, it's two-way. Why? Because the first match is wait, and the second match is local preference. So the autonomous system path, it comes after local preference matching. So this is a good one to know it. So now here, this way we don't want this. So we don't want to use this because it's not overridden. So it's make for router 6.6.6.6 also. So show IP BGP here. Look at this to see something here. Yes, go to the router 1 again and show IP BGP now. Look at this, it used this way. Yes, so it used this because it has a highest local preference, and the highest local preference it will choose because this is the first matches before path. Yes, so it takes the local preference even if it's the autonomous system path, it's too long. Yes, so that's very good. Now we are going to make router 1 choose router 3 to reach router 6. What does that mean? I mean router 1 will choose also, I want to look at this, I did here what I will. Router 1 choose to reach to the router 6 here, 6.6.6.6 through router 2. I want to choose router 3 to reach to the router 6. I want to use local preference here 300. So I want to go back to the router 3. Look at this. I want to go to the router 3 and also I want to make the local preference of router 6 loopback interface 6.6.6.6 to give it 300 because router 1 I want to choose this way to go to the router 6, not this way. So go to make access list here with 1 with permit 6.6.6.0, yes, with 0.0.0.255. I want to match this with route map, so I want to make a local preference for router yes, to go to the router 5. Let me see, just 5 because I want to match this through this way, just it's a name. So now with sequence number this, I want to match IP address, yes, this access list number 1, set local preference, here is I want 300, otherwise anything I want just to deny it with sequence with the second line of route map. This is very, very important to do it. So now I want to conf t to go to the router BGP 100. I want to apply this access list, yes, through this command because this is neighboring with this line 192.172.16.0.6. I want here if the router 6, yes, if this loopback interface, yes, 6.6.6.6 comes in from this way, please give it the local preference with 300. So now here is I want to make route map, and this local route map here is I want to in, not out. So that's now I want to make clear IP BGP star soft. Now go to the router 1. It should look at this. The first thing 6.6 it use this way through router 2 because it has a local preference higher than router 3. Now it should change to the router 3. Look at this, router 6 here change this way to the through router 3 because it has a highest local preference. Look at this, it use the highest local 300. So this is a good one to know it. So we did this through local preference here. So now go back to our points here. So we finished this. We did the router 1 to choose router 3 because we changed the local preference for interface loopback 6.6.6.6 to the 300. So now the point number 6 here, I want to make router 1 to choose router 3 to reach to this loopback interface. Local preference is 400, but here I don't want to use access list. Here is I don't want to use access list. Look at this, I want just, here's my condition, don't use access list. So what I really want to do here, I don't want to make this to use access list. So go to the router 3 here, go back. yes, I want to router 1 to reach to the router 6, loop back 6 through this way. Before that, go to the router 1 just to verify it. Router 1, choose 60, yes, through this way, through router 2, through this way, because it has a highest local preference. But here is I want to make a highest local preference for 60.60.60.60, but without use access list. Look at this, look, show access list here. I have one access list, yes, for the first route map, and the second one I want to use here is IP prefix list. So I want to use a prefix list here, prefix list with name, let's say local preference for 60, which means for 60.60.60.60. Now I want to use permit here to permit my network 60.60.60.0/24. Just I want to use just like this. I want to apply this with route map. Yes, route map here. I want to use the last here. Look at this, show route. I want to use something interesting here. I want to use the same route map, but in the second line. Yes, in the second. I want to apply this in the second line, and sequence number 2. So this is very, very interesting to know it. So I want to use route map here with this name. But here, look at this, be careful to permit to put it 20, not 10. If you do 10, you will override this. So now go to 20 and match the IP prefix, match prefix list. What is this? Match the IP, let me see here, the IP address. Yes, prefix list, sorry. Now here is like this. Match this. What is the name of prefix list? Just to, yes, here's it. Now paste it just like this and set the local preference. What is the local preference here? I want just to make local preference 400, yes, to make it 400. Go to the router 3 again. Here is it. Now make it 300. Now I want to make a third line of route map 30. So otherwise than this, denied. This is very, very important to do it. Now I want to apply in BGP 100. I want to use a neighbor. So it's applied by default. Yes, show run. I want to show you it's applied. I don't need to apply again because it has the same route map which applied before, like this. Here's it. Look at this. I applied, yes, applied the same route map. So just I want to make clear IP BGP star soft. Go to the router 1. Now it will change. Yes, it is IC router. This loopback interface, choose router 2. Now it must change to the router 3 because the local preference is higher than this. So show IP BGP. Let me see here. Give me some shooting now. Yes, that's it. 60. Choose this way because it has, yes, it has a higher local preference than router 2. So this is very, very good to know it. So what we did here, yes, we finished the point number 6. Yes, we make router 1 to choose router 3 to reach this loopback interface through this local preference. We didn't use the access list, we used just prefix list. The point number 7 now, it's very, very interesting. Yes, make router 1 to choose router 3 to reach the all routes in autonomous system 400 with local preference 500. So look at this. I want to here router 1 to reach to all network here, to all networks on autonomous system 400. Yes, 400 to reach through router 3. If we go to the router 1 and look at this, it choose, yes, it choose the router 2 here because it has the highest local preference to go to the router 4. And also our network here also 192.168.5.5. What is it? Here is it. Yes, use also this way. So also this, look at this, use this way. So look at this, very, very interesting to know something here. My condition here, it says I don't want to use access list, either prefix list. So what I want to do here, and also I want to permit all networks in autonomous system 4. So what does that mean? I want to do it if in the future, if someone else add another network, I want to advertise it also. So I don't want to accept list or to deny any networks. I want to apply in or to permit all networks for router 5. So this is, I want to use it something called autonomous system path. So now I want to show you how to use autonomous system path, not prepended, but here is an autonomous system path. I want to show you how to do this. Just before that, I want to go to the router 1. I want to show IP, BGP. Something here is, it's called regexp. This regexp, it will show you the all networks comes from 400. I want to see all networks come from 400 autonomous system. So this, I want to use this cap, and I want to hit the autonomous system number with US dollars signs. Now hit enter. Look at this. I can see all networks comes from this autonomous system. Yes, we have 3 networks here. Yes, so that's very, very nice to know it. Yes, because here is 500. Yes, 500. Yes, and if I did show IP BGP again, 500 through this way, comes through this way because it has a highest local preference, and also 192.168.5.0, here is it also, and 172.16.0.4 also through this way. So I want to change the path to go through router 3. So now through change the local preference to 400, yes, to 500, sorry, change local preference. But here's, I want to use autonomous system path, not IP access list or prefix list. So go to the router 3, conf t. Now I want to show you how to do this. IP autonomous system path, yes, with access list here, access list number 1, but this access list is contact with this. So this is, now here's, I want to make permit. Now I want to make a line. The line here is like I did before on router 1, like this, the cap with 400 with the sign dollars here. What I mean, I want to allow all networks comes from this autonomous system. Yes, so hit enter now. I want to apply this in route map. So the same route map, here is it, show route map. I want to apply in this route map, but in this line, in the third line. Yes, to apply it in the third line. So conf t route map with this local name. Here is permit. Be careful to do it on this 30. So now like this, I want to match IB autonomous system IB access list with IB address. Sorry, to apply this, just yes, with IP address with access list number. Here is, I should change it, you know, because I don't want to apply. Here is, look at this, match autonomous system path, yes, with autonomous system path with 1, like this. Yes, not access list. So this is a good one. Now set the local preference with 400. Yes, 400. So did this 400, sorry. So now what I want to do here, just be careful to make a second line of route map with 40 to deny anything doesn't match this. This is very important. Now I want to make clear IP BGP star soft. So now go to the router 1. Now it should change. Now show IP BGP. Look at this. I have 5. Look at this 5. It changed the rule. Yes, changed it. Take this way. And also 192 take this way also. And this is that 4 also take this way. So all networks here included or attached with autonomous system 500, it takes the local preference with 400. So router 1 can reach to all network of autonomous system 400, yes, with local preference 500. So I did this by autonomous system path, not access list or prefix list. So this is very, very important to know. Now I want to jump to the or to move to the last one. The last one here, I want to make load share balancing between router 2 and router 4. Look at this. Here's I have 2 links, but in the first video I used just the upper link. Now I want to use the second one. Here is it. I want to make a load sharing. If I used the neighborship between router 2 and router 4 for in these IP addresses of serials, here is I can't achieve the load balancing or load sharing. So what I want to do here, I want to make a neighboring with loopback interfaces for each router. So I want router 2 to make neighborship between router 4 through loopback interface of router 4, and also router 4 make neighborship between router 2 through loopback interface of router 2. And also here I want to use the command of the BGP the external BGP hop, and also I want to use a static route. So what I want to do here, go to the router 2. Just I want to show you something here. Show IP interface brief. Just I want to make sure, yes, the second one it has this IP address, yes, and show run. I want just to delete the last look at this. Just I want to show you something here. Before I did this, I want to make a neighbor with the second line, yes, and I want to see yes, conf t, what is that? Conf t interface router BGP 100. I want to make a neighbor because here I has just neighbor with this. I want to make a neighbor also with the second one, neighboring with 172.16.1.4 with remote autonomous system 200. And also in router 4, look at this. Just I want to show you here, if I did this I can't achieve the load sharing. So conf t router BGP, here's 200. I want to make a neighbor with 172.16.1.2 with remote autonomous system 100 here. Yes, I want to show IP BGP here. Look at this. I can't use, look at this, it used just this way, one way, so I can't make show IP BGP again. So look at this, I can't see just one. If I go to the router 2 again, if I did trace route to the 4.4.4.4, look at this, so 172.16. Look at this, just like this. I choose the first line, yes, not the second one. Again, choose the first one. Look at this. I want to make, if I did the trace route to this network, I should use the load balancing here. So what I want to do, just remember this step. This trace route and the output here is just one IP address through one link. I want, if I make a trace route, it should be make between load balancing between 2 lines, through 2 lines here. So now I want to conf t, just I want to remove the last neighborship. So router BGP 100 I want to use no neighborship 172.16.0.2 with remote autonomous system, sorry, 200. And also the second one is 1.4, this is, and also here I want to remove it also on router 4, sorry, in router 4. Yes, conft router BGP with 200. I want to no neighborship between 172.16.0.1 with remote autonomous system 100, and also I want to remove with 1.2. So now it's clear now. So now I don't see do show IP BGP. Look at this. Yes, I can't see anything through this 172.16.0.2 or 0.4. I don't see anything here because I deleted. Now I want to make a neighborship between from router 2 to reach the router 4 through loopback interface. So here is neighbor with loopback interface of router 4 like this with remote autonomous system, sorry, remote autonomous system 200. Yes, just like this, one neighboring. And here is I want to use neighbor 4.4.4.4 with external BGP multi-hop. Here is I can't use 2 because here is I have 2 hops. Just go back here and go back here. So router 2 go to the router 4, I come back to the router 2, just 2 hop. If I did it by default, it will use 255. So I don't want this. So I want to choose 2. So now let's go to the router 4. Here is also, before I move to the router 4, I need also the static route here, because here is I don't include this 2 or this yes, this the loopback interface of router 2 included in the EIGRB or OSPF. So here is I need the static route to reach to the loopback interface of router 4 through 2 serials. So I want to just show IP route to go to the 4.4.4.4 255 through 172.116.0.2. So the first one I want to reach to the loopback interface of router 4 through the upper link, and the second one I want to reach it through the lower link with 1.4. So this is very, very important to do it. So now go to the router 4. Now I want to make a neighbor through the loopback interface of router 2 to the 2.2 with remote autonomous, sorry, yes, with remote autonomous system 100. Don't forget to make external BGP multi-hop, yes, with 2 multi-hop. Here is also I need the static route, because here I don't have the EIGRB or OSPF or REP to attach 2 router ID between each other. So here is I want to use IP route here, static route, to go to 255 through 172.16.0.1, the upper link here. This complete command, this IP route is 0.1, sorry. Now the second line is the lowest one, so the 1.2. So now if I go to the router 1, look at this, and show IP BGP here, look at this, just I can see router 4, yes. Look at this, if I make a trace route, sorry, if I did a trace route through 4.4.4.4, yes, it choose through 172, because it's, yes, it's prefer, yes, because it's prefer to the router 3 here. So I'm in router 1, so just router 1, just stupid mistake. What is that? I want router 2 here. Show IP BGP, yes, show IP BGP. Yes, this is router 4, so go to make a trace, make a trace route 4.4.4.4. Look at this now. I see the load balancing between two links. Before that, just I was see this loop back this way. So this is very important to know it. So this is very good to know. So we did a load balancing between external eBGP multi-hop. So that's a good one. Yes. So that's very nice one to do. So that was everything today. In this video we talked about 8 things. We configured the OSPF with area 0 and we configured the iBGP and eBGP. We did the router 1 to reach to all networks, look back, and we saw how we can do this through advertise the network through BGP. And also we did the router 1 to choose the router 5, yes, to reach the router 6. We didn't use the local preference or MED. We did this by autonomous system path prepended on router 6, and we saw how we can do this. The point 4, we made all outside network to go through router 2 by local preference 200. We did this also, and also we made the router 1 to choose router 3 to reach to this loopback interface through this local preference. And also we did this the 6th point. We made the router 1 to choose router 3 to reach this loopback interface of router 6 with this local preference. We didn't use access list. We did this by prefix list. So, and the last thing, we did it in make router 1 to choose router 3. Yes, all autonomous system on 400 to use 500 local preference. We didn't use access list or prefix list. We did this by autonomous system path access list. So, and the last one, we made a load sharing balancing between router 2 and router 4. So all of these points we did it in this video, and I hope it's valuable for you and beneficial for everyone wants to know about the BGP. So that was everything, and I hope to see you in the next video, and bye bye.